Bismillahirrahmanirrahim. Assalamu alaikum. Our today's topic is about electrochemistry, chapter number 8. In this chapter, we will study the introduction, electrolytes and non-electrolytes, electrolysis and or non-electrolytic conductions, electrolysis of molten sodium chloride, and electrolysis of water. Electrolytes and non-electrolytes. Now, electrolytes. The chemical compound which conduct electricity in molten conditions or through its aqueous solutions with chemical change is called electrolyte. And non-electrolytes, the chemical compounds which do not conduct electricity in molten or in aqueous solutions are called non-electrolytes, such as sugar, petrol, benzene, etc. Electrolysis or non-electrolytic conductions. The electrolysis may be defined as a process in which movements of the ions take place towards their respective electrodes to undergo chemical change under the influence of the applied electric field. Now, the electrolysis of molten sodium chloride. Sodium chloride, that is common salt, does not conduct electricity in the solid state. To make it conduct electricity, either fuse or melt the salt or dissolve it in water. So, there are two ways of doing electrolysis of sodium chloride. Ways of doing electrolysis of molten sodium chloride. Sodium chloride melts at 800 degrees centigrade. It is easy to predict the result of electrolysis of molten electrolyte. The salt just splits into two parts. Sodium metal, positive ion, that is Na positive, and chloride, non-metal, negative ion, that is Cl negative. We can write the ionization reaction as NaCl. When it fused, it dissociates into Na positive and Cl negative. Some fused NaCl is taken in an electrolytic cell, that is in a glass vessel. Two platinum rods or two platinum electrodes are dipped into the fused salt. The two electrodes are connected to a source of electricity, that is to a battery outside the cell by wires. The electrode connected to the negative terminal of the battery is called cathode, and the electrode connected to the positive terminal of the battery is called anode. At cathode, the sodium ions, that are Na positive, which are positively charged, move towards cathode and gain electrons to get neutralized. Thus, Na positive ions are discharged at cathode and form neutral molten sodium metal. We can represent the happening at cathode as sodium ion plus electron. The product is sodium metal, that is Na positive gains electron and convert into molten sodium metal. It is at cathode, Na positive accept electron and convert into sodium metal. At anode, chloride ions, which are negatively charged, move towards anode. Cl negative ions have one electron in excess. The anode has a shortage of electrons and is positively charged. When chloride ions arrive at anode, the extra electrons at anode forming neutral chlorine atoms, but we know chlorine atoms do not exist in the free state. They combine to form chlorine molecules. So, chloride ions are discharged at anode to liberate Cl gas by the loss of electrons at anode. It is a chloride ion. It discharges its electron. There are many chloride ions formed in this solution. The second chloride ion also discharges its electrons at anode, and two chlorine atoms combine together to form chlorine gas, that is Cl2 molecule. This reaction takes place at anode because chloride ions carry negatively charged and called anion. In this electrode, due to the movement of anion, that is negatively charged ions, so this electrode is called anode. And this electrode, which is connected to the positive terminal, to the negative terminal of the battery, called cathode, because sodium ions, which is positively charged ions, rush towards this electrode. The positive charged ion is called cation, and it rushes towards the negative electrode. So this negative electrode is called cathode due to the movement of cation. Reaction at cathode, chloride ion in molten state loses its electron. When two chloride ions discharge, we obtain two chlorine atoms and two electrons. Then chlorine atoms are unstable and they form covalent bond because they both contain 7 electrons in their outermost shell. So they form chlorine molecule by the formation of covalent bond. The overall amount is two chloride ions form Cl2, that is chlorine gas, with the removal of 2 electrons. The overall reaction can be described as reaction at cathode. Two sodium ions gain 2 electrons and form 2 sodium metal in liquid state, that is in molten form, and 2 chloride ions remove 2 electrons and Cl2 gas is formed. Here we have 2 electrons, right? Now the overall reaction, or by adding 2 reactions, when 2 sodium ion takes 2 electron and form 2 sodium metal, 2 atom of sodium metal, and 2 chloride ions form Cl2 gas by the removal of 2 electrons. These 2 electrons, which is just obtained from chloride ions, are accepted by this sodium ion. So in the end of the reaction, we have no electron because these 2 electrons has gone into these 2 electrons move towards cathode and sodium ion accept these two electrons. So we cancel these two electrons, and at the end of the reaction we obtain, at reactant side we obtain 2Na positive plus 2Cl negative, and at the side of product we obtain 2 atom of sodium metal in molten state and Cl2 gas. The sodium metal obtained at cathode and chlorine gas obtained at anode. Now, the electrolysis of water. Consider an electrolytic cell containing acidulated water. 2 electrodes are dipped in the acidulated water. Water in the presence of few drops of acid ionizes as 2H2O. In the presence of acid, water self-ionization takes place and hydronium ion and hydroxide ions are obtained. When electricity is passed from the battery, the positive ions, that is hydronium ion H3O positive, move towards cathode. They gain electrons and get neutralized to liberate H2 gas. At cathode, cations gain electron, that is hydronium ions gains electron and H2 gas is obtained, that is hydrogen gas is obtained, and with the 2 molecule of water. Hydroxide ion move towards anode. OH negative ions lose electrons at anode and get neutralized to liberate oxygen gas. At anode, 4OH negative liberate 4 electron with the removal of O2 plus 2 molecule of water. The overall reaction should be balanced according to gain and loss of electrons at the 2 electrodes. So the cathode reaction is multiplied by 2 and then added in the anode reaction. It is a cathode reaction. The whole reaction is multiplied by 2. Now, after multiplication, we obtain 4 electron, right? 2H3O positive, 2 2s are 4, 4H3O positive, then 2 multiplied by 2 electron, then we obtain 4 electron, and then 2 molecule of H2 and 4 molecule of water are obtained. At anode, 4OH negative remove 4 electron with the liberation of O2 and 2 molecule of water. Now, after adding, we obtain 4H3O positive plus 4OH negative as a reactant, and as a product we obtain 2 molecule of hydrogen, 1 molecule of oxygen and 4 plus 2, 6 molecule of water, because 4 electron which is discharged by OH negative ion absorbed by 4 H3O positive ions. So when 4 H3O positive and 4 OH negative together will be equivalent to 8 H2O. 4 H3O positive plus 4OH negative. We have 8H2O. When electricity is passed, it converts into 2H2 plus O2 plus 6H2O, or 6 8H2O 6H2 minus 6H2O 2H2 plus O2. So 2H2O plus 2H2 plus O2. For simplicity of the electrolysis of water, we write the equation as 2H2O. When electric current is passed in the solution of water, we obtain 2 molecules of hydrogen gas as a cathode product and a molecule of oxygen gas as an anode product. So during the electrolysis of water, hydrogen gas is obtained at cathode and oxygen gas is obtained at anode. Thank you very much. Allah Hafiz.